This is Forces Problem Set 4, Question 6. The hint here is especially important for solving the problem. Determine the tension in each cable. There is an upper cable and a lower. Without even feeling like I'm doing physics, it's pretty clear that the upper cable carries more tension than the lower cable does. And that's because the upper cable has two masses hanging from it, while the lower cable only has one. Let's set about using balanced forces to understand this. Again, I always recommend you draw a force diagram. So here is the 7 kilogram mass. There's a gravitational force. There's a tension, upper cable on the 7 kilogram mass. And then look downwards below the 7 kilogram mass. There's a second downward force, F tension by the lower cable on the 7 kilogram mass. These are balanced. So I have enough information to find Fg. That'll be mass times grav field strength, or 7 times 9.8, which is 68.6 newtons. I don't know what the tension in the lower cable is. This force, don't know that. And don't know anything about this yet either. So let's keep going. Let's draw the 4 kilogram mass. So it's got a gravitational gravitational force by the Earth on the 4 kilogram mass. There's a tension force by the lower cable on the 4 kilogram mass. These forces are balanced because, as far as I know, everything is at rest here. I think this might be my key to figuring things out. The gravitational force, I can know that. That's 4 times 9.8. Which is 39.2 newtons. Please forgive me for not writing out that calculation like I did before. This is definitely preferred. I was just out of space here. Because the forces are balanced, the downwards force and the upwards force need to be the same size. The lower cable carries in it the same tension on either end. The tension here and the tension here are the same. So if I know the tension on one end of the cable, I know the tension on the other end. And now I can show this more algebraically. This one on the left will be tension force minus, upper cable tension. This is the tension by the lower cable minus the gravitational force, and all that has to equal 0. Ft, the upper cable tension, I don't know that. Lower cable tension is 39.2. We just solved that. The gravitational force on the left picture, a 7 kilogram mass, is 68.6 newtons. That's going to be 107.8 newtons. Let's just double check that that makes sense in the context of the picture. That's nearly 40 newtons down, that's nearly 70, and that's nearly 110. Yeah, that makes sense. So the question said, what is the tension in each cable? F tension in the upper cable is 107.8 newtons. F tension in the lower cable is 39.2 newtons. Now, elements that I need you to have in every solution include the following. I need to see one or more force diagrams like we've shown here. I need you to state whether or not the forces are balanced. And then finally, somehow, I need to see how you calculated any of the numbers. Writing it out like this is expected along with the numeric solution. You can either do that kind of more visually along the diagram or a little more algebraically separately from the diagram. That's your choice. I also expect that forces that are the same length, same size force, should be approximately the same size arrow length, this force and this force and this. This has been problem set 4, forces, question number 6.